So thanks for being here. We're going to be talking about the work that Humanizing Autonomy is doing around using behavioral artificial intelligence to improve road safety. The, the background of this is that in our efforts to try and find the best ways to understand what we are doing and what is the impact of what we're doing, and assessing our interventions in the projects, we found that there are different ways that we haven't really explored. And one of them is using camera-based monitoring, let's say. So Sanna Randelius is with us today. She's from Humanizing Autonomy. They are in London and whereabouts. So I'll give Sanna the floor to present both yourself and the organization, and show us what you have for us today. So thanks for coming.
Lovely, thank you very much, and great pronunciation of my Swedish name. So I'm Sanna Randelius. I'm a sales engineer at Humanising Autonomy. So I joined this company a little bit more than a year ago, but I've spent my whole career working with data and analytics in various different industries. And the last 10 years I spent at IBM looking at how we could infuse AI, so machine learning and computer vision, so video-based analytics, into operational platforms. So when I decided to move on, Humanizing Autonomy seemed like such a great company, and the whole kind of concept around behavior AI was very interesting to me. So I've had a great time here. I'm going to talk you through what behavior AI is and how we use it to improve road safety. So that's the kind of topic, the main topic of today. So I'll start off with how we work to make roads safer using this behavior AI. Then I'm actually going to dive into what we mean by behavior AI and the different verticals we operate in before I kind of go back into talking more about road safety, because you sort of need the bigger picture to understand why we are different when we talk about AI in road safety, and how our near-miss detection is different perhaps from other companies. So without further ado, let's talk about safer roads with behavior AI. So all the technology that we do at Humanizing Autonomy is about people. So we're a startup that got going in 2017, and it was all around understanding human behavior through computer vision. So we started off in the autonomous vehicle industry, where we wanted to be the human perception layer, because we wanted to create a safer world for humans to be in. So this is kind of where we started, and I'm going to talk a little bit more about the autonomous vehicle industry later and the work we've done in there. But essentially, because we started in kind of that urban environment for autonomous vehicles, it kind of lent itself to all these other use cases. So we look at how to provide safer roads through a number of different methods. So one is kind of the overarching goal to improve safety by reducing accidents and near misses, because we do believe that a near miss is a kind of key indicator that accidents could be prevalent in a specific zone. So if you have more near misses, you're probably likely to have more kind of risky behavior in that zone. The other one is around looking and responding to dangerous road events as they occur. So this is more of a real-time feature that we have. So you'll see as we go through this, we can talk about real-time detection or kind of historical detection, where we look at videos over a period of time to determine risk. So we look at the real time, and we also have this the reporting mechanism. So today we're going to focus mostly on the analytical reporting, but I will touch on the real-time aspect as well, and the different kind of methods we have to capture video and then analyze that video. And we often talk to our customers about things like traffic flow. So we talk to a lot of people that manage cities, and their main focus is around managing traffic flow or managing pollution levels. But very few of them actually look at if they divert traffic from one part of a city to another part, you know, how does that impact near misses? How does that impact road safety for the vulnerable road users? So this is a topic that we speak to many different people about, and at many different levels. But essentially, this is what we do. We try and provide a better place and a safer place for humans to interact with machines. Okay, so what is behavior AI? So artificial intelligence, if we kind of start at the basic level, is essentially about teaching machines to do human tasks. So teach a computer to read something, or to listen and understand, or to speak, or to look at an image and understand what's in that image. So these are different kind of artificial intelligence techniques. And what we want to try and do with our technology is to get the computer to get better at understanding the nuances of human behavior, because humans are really complex. So if you imagine you're either in a vehicle driving down the road, or you're looking at a video of a road and you can see pedestrians or cyclists that want to cross. As a human, we're really good at detecting, you know, which one is likely to cross. You know, oh, I can see that person looks, you know, raring to go across the street, or that's a kid, they're probably not very, you know, street savvy, so I need to watch out for that. But for computers, it's really, really difficult to understand and pick up those nuances of human behavior to really, you know, understand what a person is doing. And that is what we're trying to achieve, or what we're achieving at Humanising Autonomy with our behavior AI platform. So what we're doing is we have a way of analyzing videos, but we don't just kind of detect people and say, oh, there's a person. We actually use behavior psychology to look at specific use cases. So let's say we have a use case up here, which is, does this person have an intention to cross the road or not? Okay, so what we did is we put behavioral psychologists on the streets of London that looked at people and looked at how they behaved when they were coming up to cross the road. Where are they looking? What's their orientation? Where are they on the pavement? How are they acting? Are they aware of the cars? All of these little kind of nuggets combined with statistical AI kind of bring together this likelihood score of a person crossing the road. So you may ask, like, why is that important to know? Well, actually, when we start analyzing videos that have hundreds of people in them, and we're trying to tell you whether it's a near miss, like, we really need to understand the nuance of what a person is doing. We don't just want to know if they're near a vehicle. We want to know if they have an intention to actually cross that road. So another thing that is somewhat different, that makes us different from other companies, is we have this proprietary data set. So when we started in 2017, we started building this data set up, and we have over 200 million people in this data set, and we've analyzed over a billion human behaviors, and we think this is the world's largest data set of human behaviors. And as a company, we're very diverse. We have people from 15 different nations. We believe if you're going to understand humans, you need to kind of ensure that you include all humans in that. So we do that kind of at work, and we do it in the partners that we work with. So we have data about people from all over the world, and we validate any of these use cases that we come up with, that they are as relevant in Japan as they are in Vietnam, as they are in Colombia, as they are in London. So that's kind of what goes on under the hood. You don't need to kind of fully understand what all of this is, but just kind of understand that we are slightly more advanced than just you know, detecting people. So if we look at actually how would you interact with us, because we have these algorithms, and we can analyze your video, but we are not like a fully fledged smarter city platform, because that's not where our expertise is. So we are a computer vision company. So this is the subset of artificial intelligence that analyze a video or a series, a photo or a series of photos in a video clip to infer what's going on. So we can train our models based on our proprietary data set to detect things like people or vehicles or cyclists or e-scooterists, and we can train it to track them over time. We don't identify anyone, we don't do any facial recognition, but we do track people over time, so we have an understanding of how they move around in a video. And we can essentially connect to any camera. We're camera agnostic. Obviously, you know, if the resolution is very poor or the frames per second is very poor, the output isn't going to be as good, but we are camera agnostic. You can provide us with videos for a specific junction or from a vehicle, and we can analyze those and tell you where risky events are. So we take that video and we put it into what we call our behavior AI platform, and we can do things like extract who we detected, you know, person, cyclists, etc. We can detect near misses. So where was there a near miss in this kind of blurry junction? We can look at tracking over time. So where are people moving? We can do things like count people, and this is actually quite relevant because if you're looking at near misses over time, if you see an area where near misses start going up, actually it could just be because you have a lot more people moving around that particular area. So you need to kind of normalize it and make sure that you take that into account. But we can look at things like movement paths. You know, are people moving across the environment as designed, or are they not? Because if they're not, you know, that may increase the risk in specific areas. And things like dwelling times, etc. So there's a lot of things that we can extract from this video that we can then pass on to you as a data file. So we're similarly agnostic how you consume our output. So you can take the data just on its own and analyze it and go, actually, for this particular junction, we can see there's risk here. Let's go and investigate why that is. You could put it into a platform. Maybe you already have some kind of safety platform that you look at. We could become another data input layer, or maybe we'll just produce reports. You know, we are quite happy to accommodate whatever your requirements are with that. And our data can be consumed either standalone, if you're just looking at near misses. So if we look at low and medium income countries, you may not have a lot of other connected systems. So in that case, we can just look at our data on our own. If you have other connected systems, then, you know, we can combine it with other data and look at other reasons for things that perhaps are the root cause of near misses. All right, so from there, I'm going to talk about verticals before I go back and speak a bit more about the projects that we have done for smarter cities and for kind of road safety in general. And the reason I want to cover the verticals is because it gives you a background to how you could actually collect data, because there are a number of different ways. So as I said earlier, we started off in the autonomous vehicle industry, and we wanted to be the perception layer for humans, because autonomous vehicles work great when they drive around in Arizona. You know, there's just cacti and some other vehicles. You know, cars are pretty predictable in their behavior, so it's quite easy to have an autonomous vehicle doing that. But you take that same autonomous vehicle and you put it in Soho in London on a Friday night, and it's going to be so shy it can't move because it has no idea what people are doing. You know, it doesn't know if a person's waving their hand, if that means stop or hello or taxi. You know, humans are really complicated. So this is where we started in the autonomous vehicle industry, but we also realized very quickly that actually we can take a lot of that technology. Remember, we have all these small components like Lego, so we can kind of assemble them slightly differently, and we put them into the aftermarket driver assist system. So this is where we have vehicles that are equipped after they've been manufactured with real-time alerts. So like forward collision alerts, blind spot detection, rear detection. So this contributes to kind of reducing road safety accidents by having those real-time alerts. And we operate in that. So we work together with hardware companies that produce the cameras and the screens, etc. We are just that detection layer. From there, we also work with things like public transport and fleet management. So these vehicles could either have cameras mounted by the original manufacturer or by one of these aftermarket companies. But what we also do for these is we upload videos to the cloud, and we use that cloud analytics to analyze risky behavior. And this can kind of feed into this whole understanding where risk is in your city. And you'll see that in my first use case I'm about to move on to. So this is also a way that if you are operating in a low or a middle income country where you don't have CCTV, because you may not, we're working currently with a city in America, and they are not using CCTV because it's a city where they can't, people don't tolerate CCTV. So they have to do this via buses. So it's just something to kind of keep in mind for how you want to deploy this. And then what happened is we took all of this technology that we've developed for the mobility market, and we said, like, why don't we use it for smarter cities? Okay, the camera will not be in the ego vehicle, it will be up on a fixed place, but we still understand the interaction between a human and a vehicle, and we can still understand that risk. So what you can see here is that for each vertical we work in, we kind of piggyback into other verticals, and we can reuse our technology across these. And if we improve it in one, it will be improved for all of them. So that's kind of how our solution works. So after that slow meander into what behavior AI is and our verticals, I'm going to go back in and talk a bit about what we're doing for road safety and near miss detection. So we have two projects that I can talk about. So this is a project we did with SIVA. It was pretty much completed as I joined Humanising Autonomy last year. But essentially what SIVA wanted to do is they wanted to get an understanding of dangerous driving events by their drivers. So we put dash cameras on a number of their vehicles, and we analyzed over 1,000 hours of video footage. And the good news is, like, 99% of it was irrelevant. Nothing dangerous happened, it was just routine. So that was really good. But we did identify over 8,000 driving events as well. And we were looking at things like detection and counts. So this goes back to me saying, like, make sure you count the number of vulnerable road users as you compare it to near misses, because you're likely to have more near misses the more people are about. But we also looked at near miss detection. So we can see over here on the map, we actually mark this up. So we have harsh brakes. So this is when a driver does an aggressive brake and it goes over a certain number of G-force level, and it gets registered. And we have near misses. And what SIVA could do is they could use this to, for them, they weren't looking at kind of changing the road. They were looking at changing their driver behavior. But they could use this to change routes, etc. And some of the insights examples that we got for this, over the time of this project, they actually reduced near misses by over 20%, because the drivers were more aware of the risk of this behavior, and they were more aware of what it looked like and how they should approach this differently. And this is very much what we're doing with fleets. We work with the coaches to allow them to better coach drivers. We also realized that powered two-wheelers, so motorbikes, are 5 times more likely to cause a near miss than any other vulnerable road user category, which, if you've been to London, it's probably not a big surprise. And also, most near misses was on a Thursday. The Thursday number I hear a lot. Thursdays are apparently a very bad day for near misses. But this whole project allowed us to kind of analyze risk and to see where near misses were. And if you are someone who's looking at road safety from the point of view of improving the actual road or the junction, you can take data like this and apply it to your junction or your area, and kind of see where the hotspots are, and analyze together with other data, or visit the scene to see if there's something you should change. The other project that we have done is in South America, and this one's actually quite interesting, because remember what I said at the beginning, that humans are really good at nuances. Like, we're really good at detecting when there's risk, but we scale really badly. I'm going to show you one of these videos later. We can't detect things the way a computer can. And if we look at these three use cases, they're actually quite different. So the first one, we had almost 40,000 detections, so 40,000 objects, but we only had 27 near misses. And when we see this video later, we can see like it's equally busy on this side as it is on this side. But actually, this was the more dangerous road. As a human, you wouldn't be able to look at this video and state that categorically because there's just too much going on. And then this one, actually, it's just kind of shy of twice as many people as here, but actually the near misses is vast, like 301 near misses. So if we want to reduce risk at this junction, like we really need to go in and look at the near misses and understand what is the behavior that is leading to these near misses. And also this one, so not that many detection, but actually quite safe. Okay. And one of the things that I think is interesting about this is when you analyze like the root cause of something and you try and kind of work out like what's going wrong, one good way of doing it is also looking at what's going right. So for these kind of sites where we had very few near misses, like what is going on there? What is the road furniture? How are people moving around? Are they more compliant? So it's one of these where we can also go in and look at what good looks like versus what bad looks like when we make decisions about road layout or new road furniture. Okay, so these were from existing type cameras. And if we go and look at what we mean by a near miss. So as I said earlier, like we think a near miss is an indicator of where there could be risk for accidents. So I know a lot of risk is assessed by injuries and death, but we don't want to, you know, if we change something in the road layout, we don't want to wait until someone has an injury or die before we can do a risk assessment. So what we're trying to assess here is near miss a suitable indicator for risk. I'm going to show you two different near misses. They are kind of different. Okay, so this first one doesn't really use that much behavior AI because it's mostly just physics based. So we're not really looking at the orientation or where he's looking or if he's aware. It's mostly just like, where is this guy going and where is he in conjunction with other vehicles? It's still really valid data to collect. And actually what you'll see here is this first vehicle, we will get a near miss alert because he was quite close to him. And you know what, I'm pretty sure this guy and I'm pretty sure this guy are probably totally comfortable with that interaction, but it is still risky behavior, you know. And actually what you can see here, as the vehicle has gone past him, you can actually see he increased his step length because he's just spotted this motorbike. So he actually takes like 3 or 4 really quick steps, and yet again risky behavior. But we don't get a near miss with the motorbike because the motorbike passes behind him. Okay, so physics based. Even though they're closed, it's not a near miss because, you know, he's going this way, he's going that way. We're also not recording a near miss with this guy, even though he's on the pavement, because the motorbike is too far away from him. So this is when it's kind of important to accurately code what is a near miss and what isn't a near miss, because otherwise, if you just look at like the distance between a vehicle and a person, you're going to get a lot of false positives. So that was the first near miss. The second near miss actually has more behavior AI aspects in it. So let me just maximize this screen. And I'm going to tell you a little bit about what's going on here. Is we have 2 ladies that are walking along this street here, and we get a green arrow in front of them, and that's our projected trajectory for them. So that's based on kind of like direction and velocity, but it's also based on human behavior. So we base this on things like body orientation. Like if they change body orientation, we know, because we've applied behavioral psychology to this, that is a contributor to them wanting to change direction. And in this case, that means rather than walking along this road safely, they're possibly wanting to cross this street. So this is where we think their intention to cross score goes up. and if they are within the vicinity of a vehicle, we can count that as a near miss. So what you will see here is they'll continue walking, and then as a yellow taxi comes up, they're kind of turning, and we record that as a near miss. So I will let this play. And here's the yellow taxi now, and just as that comes up, they turn. Okay, you can barely see it because the bounding box is over. And at that point, our system doesn't know if they turn and are about to step out or not, but we've recorded it as a near miss because their intention to cross this road just went straight up. Okay, and actually what happens after that is they remain stationary. So actually their intention to cross goes down, and we can see they're just green. So the next vehicle, we don't record a near miss because actually they're just standing there waiting. Okay, so that's where the behavior AI aspect comes in, where we're not just looking at how close people are, we're actually looking at their behavior for us to understand the risk level. So let me play that one again. Oh, pardon me. Let's see if I can play that one again so you can kind of see what's happening. So they're walking up, they turn. As they turn, we have a near miss. As they're stationary, our other models kick in and say actually they're not at a risk now. Okay, so that's the behavior AI aspect. So this is the 1 billion human behaviors that we've trained our data on that really understands. So we're getting more and more like a human to understand those nuances of human behavior. So if we move on from there, we can also do near misses from a vehicle. So this is a video uploaded from a vehicle. So if you're operating in rural areas where you don't have CCTV, but you're still capturing videos. So I saw there were some people from Save the Children invited on this call, and from the Red Cross, for example. Like, you will have vehicles that are moving around these type of areas. You know, if you're capturing videos, you know, we can analyze them. So in this case, we have a near miss event with this gentleman here because he's on the road. And actually, as we continue on, this lady is also on the road, but actually she actually steps off the road as we come there. So we kind of look at segmentation as well. So she's no longer on the road, and we're deeming that she's safe because we're moving here. But if we analyze videos like this, we can look at, okay, so is there a way we can improve where people move around in a road like this based on the number of near misses? Moving on. So I'm going to return to this video because it's actually quite an interesting video, just to kind of compare humans to computers. So essentially this was the output of it. We did the trajectories where people move around, and we knew how many people moved around, and we knew where the danger zone was. But if you look at this video, and imagine if you try and do that as a human, like, how can we analyze like what the risk is here as a human being? Like, people are standing very close to this road, but we're not alerting them as near misses because they're not really moving around. But there's so much going on. So as a human, yeah, you can detect risky behavior, but there is no way we could watch this video for hours and hours and tell you that actually this side is much more dangerous than this side, because we just, you know, it's too complex. There's too many things going on in videos like this. And this is where computer vision is really helpful, because it allows us to not only detect things like near misses, but also movement patterns. So for example, we could just overlay this image with where vulnerable road users move. So like, are there patterns where they dwell? So we get a lot of people that kind of stand around on these small side roads. And you know, like, if you have that information, can you use that information to make decisions about perhaps putting a pedestrian crossing in or something like that? And that's why some of these are useful. And it also allows you to analyze something over a longer period of time. So you're not just getting outliers. Like, if you just look at 1 or 2 hours, you may get a lot of outliers, but not actually kind of what normal looks like. So that's another benefit of using something like computer vision for this. Okay. So then moving on. So the areas that we normally work in to use kind of near miss insights, the two standard ones that Humanizing Autonomy work with is fixed junction CCTV. So this is where we take advantage of CCTV that's already out there, and we just analyze the junction for things like movement patterns, counts, trajectories, near misses, kind of anything that's relevant for understanding the risk in that particular junction. The other one is this onboard vehicle camera. So if you have a vehicle with cameras, we can analyze that, and we can, especially if you've got GPS data, we can note where risky events happened, and you could use that as an input into understanding where risky areas are. The other thing that I've been talking to Carlos about this as well, is actually, can we use this to kind of measure the effectiveness or the risk with either temporary interventions or permanent interventions? So, for example, if we're going to do a roadworks, we can actually put up a temporary camera and just measure the road or the junction prior to the roadworks, during the roadworks, and after the roadworks. And based on that, we can look if there were near misses, or we can look at the movement patterns of people and see if we can learn lessons to, how do we make roadworks safer. The other thing is around, if we put in like a road safety intervention. So here we have something called a floating bus stop. In the video I'm going to show you next, you'll see where perhaps a floating bus stop would be useful. This is essentially where the cyclists come in, they come off the road and they actually cycle behind the bus stop, rather than come out in traffic, and then pedestrians have to cross over here and just watch the cyclists. But actually it turns out that this is quite dangerous for blind people because they can't really hear the cyclists. So, but how do you measure that, right? How do you measure when you put something like this in, what the risk is? Okay, so that's what we're saying, that, by using video-based analytics, we can do that for these different scenarios. Another aspect that we will look at, and I'm going to talk a little bit about this in my, I'm almost finished my final video, but what are the root causes of near misses? So Humanising Autonomy, we just provide you with the information where risky events happen. It's then up to the consumers of our data to understand why they happen. So is it because there's a new layout? Is it because there are new micromobility vehicles? When I moved to London in the 90s, it's a different London now, with regards to e-scooters and cyclists and e-cyclists and electronic vehicles. It's a lot harder to navigate. But are the new public transports, are we near a hub? Is there a special event? Is there a conference in a hotel or a concert, or is there a matinee at the theatre? So there's a lot of different things that can kind of feed into understanding the root cause of this. And what we're trying to do is to kind of work out what the minimum is that we need to determine if something is risky or not. Because one of the goals that Carlos has is to take this to low and middle income countries, right? To understand risky junctions in a country where we don't have access to perhaps as much CCTV footage as we do in the UK. Okay, so I'm going to finish off. I got one more slide and then just one little graph. I'm going to finish off with this. It's actually outside our office in London, and this kind of highlights a lot of the things I've just spoken about. So our office is actually up here in a palace called, or a house called Somerset House. It was owned by some rich man, but it's kind of a collective of art and startups. It's a really nice, vibrant place to work in. But actually what you will see in this video is on the left here, we actually have a railing, and this railing is permanent, but it's come up not that long ago, and it was after a terrorist attack on Westminster Bridge where someone mounted the pavement with the vehicle. So what they did in London is they put these up everywhere, and this has had an impact on the traffic flow here, because what you can't see here is behind us on this bridge is Waterloo Station. So Waterloo Station is a massive transport hub for anyone coming in from the west or from the south. So you get a lot of people arriving here that are either commuters or tourists that will walk across this bridge or Westminster Bridge. And because we have a whole lane here for micromobility, we get a lot of cycles here and a lot of e-scooters, and we have rental cycles, etc. So there's a lot of kind of action going on here. But what actually happens if we move this along, so you'll see the bus pulls in, okay? So actually, as soon as this extra lane finishes, there's a bus stop. They haven't moved it. It's in the same place as it's always been. And every time I walk across this bridge, I kind of watch cyclists almost have an accident. No one's having an accident in this one. I'm just using it for illustration. But essentially, this guy who's the bus driver, he'll know that this is a dangerous spot, so he'll be aware. This guy, he looks like he does this cycle every year. Every day. He probably also know this is dangerous. This person, he may not have a clue that a cyclist is about to come out in front of him. So what actually happens is cyclists have to then enter traffic. Luckily, he spotted him, he stopped, but it's a bit awkward as he kind of moves around, and then they move over. And if we actually skip forwards a little bit, we can see we're sitting on a bus. We get another cyclist that's squeezing through and then crossing in front of there. And then I move forward again. We can actually see here the light is about to turn green, and this traffic starts as another cyclist comes in, and then she just sneaks in front of that bus before he starts moving. So here is a perfect example of when they put those banisters up, you know, should they have done a risk assessment? Should they have cameras here to kind of analyze this risky behavior, because it's every day, all day, with cyclists wearing in and out of this traffic. If we then continue this video, I just want to kind of show a couple of other points. So first of all, when I watched this video, I was like, oh, this must be like a Sunday morning because there's no one here. And actually, if you go to this junction now, it's hundreds of people. And then I realized actually it was 23rd of the 9th was actually a Thursday, but it was 2021. So we were just coming out of lockdown in England and no one was going to London. So this junction, which normally has hundreds of people around it, on this day only had a few people. But what's interesting about this junction and things you may want to consider when you look at dangerous behavior is you have Somerset House where we work and lots of other people work. Up here, you have the London School of Economics, hundreds and hundreds, if not thousands of students. They know this area really well. There's other people here that work here. So when we cross this road, because it's a really annoying crossing, like a lot of people run on red. But the problem with that is you have the Lyceum Theatre where the Lion King is. You have another theatre down here. Just over on the left here is Trafalgar Square. There's a lot of tourists around here. And when you mix tourists with people that are used to the area, like that increases the amount of near misses as well. And we also have things like roadworks here, so they close the road, so the layout is different. We have roadworks here, so we can see that, you know, people are crossing the road in a way they shouldn't. So to just kind of assume that there is just one solution to a traffic problem is a fool's errand, because it's really complicated. But what we can do at Humanising Autonomy is we can do this. We can take video data, analyze it. You can combine that with either your institutional knowledge of road safety or with other data, and kind of get that full view of where there's risk, why there's risk, and then you can use that to address, you know, how to reduce that risk. So, and here's our team, our very diverse team, 15 countries. And that was it.
Thank you very much, Sanna. That was really interesting to see, and especially the video where the guy on the bicycle was going counterflow along a dedicated busway. So thankfully he wasn't killed. Okay, I'm going to open it up for questions. I know that there's a few of us only, but I have a lot of questions, but would rather hear from others in case they do. Feel free to open your mic and ask a question or write it in the chat.
Hey, can you hear me?
Hi. Yeah, we can hear you. Go ahead.
Yeah, all right, perfect. Hi, Sanna. Thanks a lot for the presentation. It was quite interesting to see this because we've also been trying out this whole AI thing in India. But I just want to add one question regarding was that how has this been tried out in in shared streets specifically, where the street section is not as well defined or the street edge is not as well defined. How well does this work or does not work?
So the street is it the street segmentation that you're specifically talking about?
Yeah.
Yeah. So what we can do for traffic junctions is that if we have a specific junction, we can actually enforce segmentation on the junction if we want to. So we can specify specific zones where we're interested. So we can say this is the pavement or this is not the pavement. For the roadside use case, we have segmentation. So we try and delimit like what is pavement and what is not pavement. In the case of the video from Africa, that wasn't entirely clear. We did pick it up, but it's something that we do, but you can also customize if that makes it clear. Do you have a specific example of where you tried to do this and failed, or?
So we have been doing this as part of our Botnar work in Rohtak city. It's a little second tier town close to New Delhi, and I think it's like any other Indian city where you don't have sidewalks. So people are basically walking on the carriageway, even though you may have a 6-lane road. There would not be any sidewalk, so everyone is walking on the side lane, and there's no fixed edge, right? When you have a sidewalk, you have a clear line. Yeah. But when you don't have, you have some people spilling over. You have pedestrians who are trying to overtake each other, who come into conflict sometimes.
Okay, is that camera a fixed camera or is it a camera? Are you analyzing video from a vehicle? Okay, so from a fixed camera, the way we would approach that is we would probably go in and put different zones of interest in. So we would perhaps delimit an area as like a pavement or walking area. And if they're within that zone, it's okay. And then we would delimit other areas and say, this is actually the road area. And one of the things I didn't actually clarify when I spoke about this kind of Lego approach is like we have a Lego approach on models, but we also have the ability to configure the logic statement on top. So if a near miss in India probably will look slightly different than a near miss in London compared to a near miss in Japan, right? Like in Japan, they love their autonomous vehicles because everyone follows the rules. I mean, I do because I'm Swedish, but so for that, if there are very specific use cases, we probably, we can configure it as well. So did that answer your question?
Yeah, definitely. Thanks a lot.
Great. Yeah, thanks for that, because it starts getting it into the reality of what we're working on. So in anybody else, you can just interrupt. But I wanted to ask, I mean, so you said that you have already the data set, and I guess the question that everybody wants to answer always when they see one of these solutions is it already ready and I guess labeled and trained for any other geography, or like in the case of I guess, so some of the grantees are, of course, as Advait was describing in India, but there's also people in Vietnam, somewhere in Mexico. But yeah, so how different is it, I guess?
So I think there's kind of two parts to this answer. The first one is around human behavior. So we've validated that human behavior for things like crossing intent is fairly similar across the world. People approach a road in a similar way, that they orientate in a specific way. They look at the vehicles, like they don't walk backwards in some countries. Like people move quite similarly all across the world. So the human behavior aspect is what we've trained our models on. Then we have the environment, and that context may be slightly different. So actually yesterday when I was looking at doing this presentation, I wanted to kind of put like a picture in from somewhere else, and I actually looked at New Delhi because I visited there and the traffic was crazy, and I just thought like, oh, I can't even explain how this would work with this big road, right? So the road context may be different, and I think that links on to the question we just had. Like if the environment is very different from kind of an urban city, we have to go in and kind of approach it with like, okay, what are the areas? What are the differences? You know, do we need to put a logic filter on top? And I think it's all about, if we can understand what you're trying to understand, like what a near miss looks like to you, like we can customize it for you. But, and that's the easy stuff, right? Or easier, like the complex stuff is the human behavior, and we have.
Yeah, okay. And then I guess one other thing, while I was looking at the videos, and I guess other, like, to me, the second video, like, you have not only near misses, but you actually have an incredible amount of risky behaviors, right? Like they're walking on basically on a segregated busway. They're waiting in a very narrow, sort of lightly segregated piece of the road. And like the guy was going, like the worst was the guy on the bicycle going counterflow. And I guess all of that should be trained, or could those things be more rule-based indications? Like, could you say, if you see a bike going count, or if you see anybody crossing anywhere else, like jaywalking, isn't a good thing to be controlling actively towards people, but it is a good thing to sort of understand where it happens, so that you can, for example, say, well, you're missing a zebra crossing here, right? But is that more like a rule-based instruction to the model, or is that more of a, you have to train it and label, and like, I don't know.
It's all of these things is essentially, we would take the output of the model that understands where people are moving, where they're going, where they come from, which zones they're in, and then we can build the kind of logic filters on top of it. And there's two aspects to what you just said. One would be like a real-time type alert, where we would like real-time or near real-time alert that someone's going down the lane the wrong way. Okay, that we haven't really spoken about real-time today, but the other aspect is about looking at analyzing this over time. And what we didn't have in this screen is like the movement patterns of the pedestrians, but we could overlay that. So we could overlay where people are waiting, where they're standing, where they're going in the wrong direction. So we could provide all of that information, and then people would have to make decisions based on that. But then they'd have to look at the kind of wider environment, like, can they even put a crossing in there? Would that make sense? Or how would they in that country address that issue? Because London is different from Colombia and from India and from Japan. So you need that kind of institutional knowledge as well about how that environment operates in kind of different countries.
Right. Yeah. Okay. So I'm taking over because I have a lot of questions, but not sure if anybody else would like to chime in. Feel free.
If you got other questions as well, my email address is on there, so just kind of be in touch.
Yeah.
If someone watches this video afterwards, and
right,
just give me a shout or connect with me on LinkedIn and send me a message.
Right. Yeah, thanks. Because as I described, and of course the time, many people, it's difficult to be connected at this hour, and thanks for being here.
So I mean, maybe I'll put it back onto you, kind of based on what you've seen. So what do you feel? You know, where do you feel we can address some of the road safety issues that this group of people are trying to address?
Right. So I mean, well, the general. So of course, these sessions of the community of practice are basically to have people learn about either what they are doing in their projects or what others are doing, and they can either be inspired or follow up. Yeah. So we've been talking to different organizations or experts to sort of describe. That's the context that we're in. My view as sort of one of the supervisors of some of the grantees, specifically for Mexico, is there are places where there's been interventions that have been done as part of the program, There could be budget for example, them having some form of a camera installed before the intervention is done, and then maybe during, but definitely before and after, or maybe in some cases already identify where a camera is already in place. The main thing is how to use that, and essentially how can we like what are the characteristics of that activity so that something like what you've presented can be implemented. Do they have to, for instance, if it's going to be something that you want to see the before and after effect and be very, very clear about the actual changes and improvements, do you need 5 minutes recording before and 5 minutes after, or do you need a full week, or do you need a Thursday, for example, which I was going to ask about the Thursday phenomenon, but do you like, so what is the minimum viable product? I guess is sort of in terms of the raw material that you need to have available, for instance, in the case of what you are doing, for example.
Yeah, and I think it's a question of how long is a piece of string, but with the project that we've discussed with a third party company, you know, what we've said is maybe just 1 or 2 days may not be enough, you know, because you may just get a bunch of outliers in those couple of days. But I think it really does depend on the junction itself, or the area itself, and how much traffic you have, how many people you have. You know, if you have 2 or 3 people cross an hour, then you're going to need a lot more data. If you have like consistently a high volume of people moving around the area, then obviously, you know, the time is shorter. And I think this is one of the things we probably want to try and test out and kind of validate in this other project that we're doing, where we look at perhaps a roadwork session and we analyze it before, during, and after, to just kind of understand like what is the minimum viable product.
Right. Yeah, that makes sense. So it depends on the characteristics of and basically the behavior in the road itself.
And the representation of the different behaviors that you're looking for. Like if you have like 10 near misses an hour, like we're not going to need that much data. But if you only have 1 near miss a day, then we're going to need a lot more data to really get a representative of where the risk is.
Yeah. Okay. So before we end, so what is the third? You said Thursdays. Yeah, I want to understand the Thursday thing.
Yeah, so Thursdays, apparently, I speak to a lot of telematics companies that provide coaching to fleets. And Thursdays is often their biggest day. I think it's because it's the end of the week, so people are really tired, but it's not Friday, so they're not happy. So, and it's one of these bizarre patterns that I just keep on seeing whenever I speak about road safety and mobility. Is like Thursdays is our worst day. And I thought it was quite funny because it was the same in Siva, so I was like, I'm going to put it in. But yeah, it just shows that you need to consider other variables, right? So road safety on a Monday may be different to a Thursday, and road safety on a Saturday may be different to a Monday because different people are moving around. So there's so many different kind of variables, and we will just become one data slice into that. And then someone with institutional knowledge would do the analysis around it and kind of really get to the root cause of why things are happening.
Yeah, good. Yeah, thanks for that explanation. Okay, so I think we're done. This was really informative, and I'm sure that when people are also, not only the people who are here, but also the people who are going to be watching this recording will be very happy to learn about all these experiences. Thanks for your time, Sanna, and also Paddy, who was here listening in.
Yeah.
And in general, thanks for entertaining these ideas and sort of helping us understand what is the potential of these technologies.
That was great. Thank you so much for having us. Really appreciate it.
Okay. Thanks, everyone.
All right.
Bye.
Bye.
Ciao.
Thank you.
Thank you. Bye.